record with Zoom. Okay. All right. So today's session is called Learning to Love Errors. And the reason I decided to go with that title is because errors are something that always seem like a pain to us, or something we want to try and avoid, or trying to ignore as much as possible, because they represent something that is not going right for us. And as developers, that's very frustrating. As some of you who have been working with JavaScript for a while will know, errors are quite common, and there's a few different types of them. They happen for different reasons as well. So we're going to go over a little bit of like background information on what an error is exactly and what we can do about them. And then I'm going to give a few examples in JavaScript of how you can anticipate errors, how you can handle errors, and even how you can create errors yourself. And hopefully why you would want to create an error yourself will make sense by the end of the session. So let me share my screen for you. Okay. So you should be able to see VS Code here. I've got a few HTML pages which we're going to be looking at, and I have a blank JavaScript file, which is where we are going to be testing some of this stuff out. So if I go over here to my live server, this is the little project that I put together for this session. So errors seem like something that everyone would hate. I think that I covered that in the introduction. Like very few of us jump up and down when we see an error. It usually means that something's gone wrong and we're going to have to spend longer than we anticipated working on a particular function. Stuff like this is enough to drive you crazy. Clearly something has gone wrong, and Windows XP in this case feels the need to tell you about it many times. In fact, this is just a graphics rendering issue, but this sort of thing is pretty familiar to anyone who's been using a computer for, I don't know, 10 years or so. And it represents a lot of user frustration for the users of this operating system. They interrupt us when we're trying to get things done. So we might be using an application, say we're using a mobile banking application, and there's an error when we're trying to send a payment. That's interrupted us from completing a business transaction, potentially paying someone for something that we have purchased. It creates a real life problem. It's not just a technical issue. So this is an example of the sort of error you might see whilst browsing the internet as a user. This is Google's 504 error, and they intentionally don't give you any information because it would be a security hazard if they did. As I said, painfully unhelpful. Often errors are not appropriate to the audience they're aimed at, and they don't actually provide a solution. They just tell you about the problem. This is a perfect example of such an error. This doesn't give us any route to success. It only tells us that something went wrong. Internet Explorer doesn't know what went wrong, and the only thing we can do about it is fake the fact that we're okay about the situation. We don't have a button here that says, no, that's not okay, please try harder. They also lower our confidence in the apps we're using. So if we're constantly running into errors, or things aren't working properly and we're not getting any feedback, then that makes us trust the tools we use much less. So this is something that should be quite familiar for Mac users. This to me happens maybe on a daily basis when I'm using software that's not sort of fully finished yet. And yeah, it can happen at any time. It's frustrating, and it ultimately reduces your confidence in your tooling. Okay, so since we have decided that errors are bad, why don't we get rid of them? Why don't we just not have errors and live that way? So I didn't get too far through this, but this is a thought experiment. What would the world be like with no errors? It's much simpler. It's that much simpler. You are making fire with a stick, you're cooking with a spear, There's no planes, there's no cars, there's no nothing. Anything that involves any kind of system with an input and an output needs to have some sort of error layer. So it's not without its problems. This is more or less my vision of entering a world with no errors. Everything would break, everything would be on fire, nothing could be performed on the internet. Most importantly, without errors, we don't know when something has gone wrong. And if we are not reacting to the reality of a situation, then we're being ignorant. So errors are a type of feedback. In order to do things right, we need positive and negative feedback. If you're trying to learn to ride a bicycle and you're doing it backwards, someone needs to tell you that you're sitting on the saddle backwards. If you are doing any task that you don't know how to do perfectly, you're going to need positive enforcement and negative enforcement. And that can be things like a style guide for a developer, how you should format your code, or it can be the computer telling you that something's wrong, which is going to be an error. So we have a name for people who ignore negative feedback. We call them narcissists, which is not a very positive word to use about someone. This is a diagram of a generic person who might be a narcissist or might not be. A developer can't afford to ignore negative feedback because we're dealing with computers. So humans make mistakes all the time. That's almost a universal guarantee that humans are going to make mistakes. We have the ability to recover from our mistakes dynamically. So you're walking down the street and you trip over something. You can put your arms out in front of you and try and rebalance your body as you fall so that you don't get hurt. If you were unable to adapt, you would just fall flat on your face and break your nose every single time. So the ability to adapt is, sorry, I'm just going to check the comments. So the ability to adapt is part of what makes a human, as is the ability to make mistakes. Unfortunately, computers don't tolerate mistakes. They can't. They're not designed to. They won't be designed to for a while in the future. They are only capable of following strict routines. So if you can write a list of everything that needs to happen, you can make a computer program out of it. If something occurs during that list that you weren't anticipating, something that's not on your list as a step, then the routine breaks, and that's an error. I'm not actually sure if you're going to get volume through here, so I will just send a link to this repo when I'm done. There's also a podcast in here that I'm not going to play, but it's useful to refer to. So let's just test this and spam the chat if you can't hear it.
Don't worry, Bill. I'm not going to let my credit and good name be done in by a damn computer error.
Computers don't make errors. What they do on purpose. By now, your name and particulars have been fed into every laptop, desktop, mainframe, and supermarket scanner that collectively make up the global information conspiracy, otherwise known as the Beast.
Dale.
So that's just meant to be like, I mean, it's one of my favorite YouTube clips. I'm not going to lie. I love King of the Hill, but that's the sort of attitude that a computer has. They don't make errors. They create errors. If something goes wrong in a computer, it's because a human has failed to anticipate all of the eventualities. So there will often be mistakes. And when something unexpected happens, that's an error. Sometimes we have something that is approaching perfect code. So if you're writing a website that's low stakes, like it's a blog about rearing chickens, which is my current hobby, your security concerns aren't very high. You're not really going to be anticipating people hacking your website that much. And the information you have isn't sensitive. So the code you produce for this website doesn't need to be absolutely perfect from a sort of industrial best practices standpoint. If you are producing a banking application, if you're producing a voting machine, anything critical to some sort of business or national function, then the code has to be incredibly tightly inspected and audited to make sure that there's nothing there that shouldn't be there. And many people will read the same code and test it very thoroughly. And although nothing is ever perfect, this is what I mean by perfect code. So even if you're in this situation where many experienced developers have spent years carefully tailoring an application to make sure it basically cannot fail, it can still fail. This is a very interesting podcast from Radiolab. There's also a Veritasium video on it, and I think a couple of Tom Scott videos. They all are discussing something very strange that happened in Belgium during an election. Belgium had electronic voting machines, and in one district, a candidate who was running found that she had tens of thousands of votes, and there were only 800 people or roughly 800 people in her district. So there must have been an error somewhere. What this podcast explains is how that error happened, and it was actually due to cosmic radiation. So even when the code is fine, there's crazy, unlikely factors that can affect the operation of a computer, and those have to have an error that correspond with them. Otherwise, we never know that something went wrong. If we didn't know that there was a problem with this voting machine, then the wrong person could have been elected, for example. And that's not a matter of a user being frustrated with their computer because they can't access Instagram. That's serious. So yes, a world without errors would be chaos. We can't live without them. We have to understand them. And as front-end developers, we have to handle them, as in with our hands. So we may as well learn to love them. So I'm going to stop talking about errors broadly now, and we're going to start getting into the specific types of errors that we encounter, that we care about as developers. Not all of them are relevant. So there's going to be types of errors that a back-end developer is very familiar with. There's going to be types of errors that a DevOps engineer is very familiar with. And likewise, there'll be errors that front-end developers are keenly aware of that a back-end developer has never heard of. So it's not a case of being an expert in every single type of error in the universe. We have, broadly speaking, 3 types of errors to worry about. So these are user errors. Now these happen when the application works as it was designed to, but the user is not using the application as it was designed. So my example here is I charge my laptop with live wires from the wall and now it won't turn on. The laptop manufacturer never intended the laptop to be charged that way. They never considered what would happen if someone did try to charge it that way. And the obvious result is that you fry your power system on your laptop and it doesn't work anymore. So in this case, the error is the fault of the user, really, unless the manufacturer can be expected to handle every single case that might crop up with their machine. There's a certain trust that the user is not going to do something foolish. So as front-end developers, we have to be aware of user error, the possibility for user error, and this is the reason that we try to design foolproof applications. We try and make them simple and straightforward so that there is as little avenue for user error as possible. Runtime errors are probably the most common that we're going to encounter in this course because they affect JavaScript as the application is running. So when you are clicking on a button to load something from the API and you are supposed to send a URL and you send a number instead of a URL, and the application gets confused by that, you're going to get a uncaught type error. It's going to say, I expected one thing and I got another thing, and I don't know what to do about it. So I've just stopped execution and interrupted the application. Those are definitely the most common for JavaScript developers, but also as things get more complex and you start using JavaScript frameworks and external libraries and bundlers and that sort of thing, then you are going to run into build errors. So if you have, say, a parcel application and you're importing Moment.js to deal with dates, and you haven't installed that NPM package properly, you will receive a build error when the application is bundled together, saying that this module is missing. So inside of these, we really care the most about runtime errors, because a build error, it's a case of there being something wrong with your code and you have to investigate what the problem is with the code, which is called debugging. With a runtime error, it can be that there's something wrong with your code, or it could be that there's something unexpected happening. So it's not necessarily a case of finding the mistake you've made. It's more about isolating the conditions that cause this error to occur. Okay, so we've got a nice blank page here. I'm going to create a few errors in JavaScript, a few common errors, and we will look at them carefully. We'll read the errors carefully and try and understand what they are telling us. And then we will look at some ways to handle these errors for the user, so that when something goes wrong, if it's possible to continue, we can continue the flow of the application without interrupting the user completely. So let's switch to VS Code. All right, so one of the common tasks we do is interacting with the DOM. So I'm going to query selector a button. So we've got button equals button. And we're going to console log that button. If we open DevTools here, we get a null. That's good. Okay, so yeah, button dot okay, so let's try and get the text of a button. And here we have uncaught type error, cannot read properties of null. So that's great. Next, we're going to create a network error or a fetch error. So we're going to fetch a fake website. So it doesn't exist. It's not going to return a response because there is presumably nothing at this address. Why did that not work? Oops. Okay. Sorry, I'm just trying to create an error here, not getting it. Oh, okay, I'm not calling my function, that's why, sorry. There we go, that's better. All right, so now I've fixed that. If we run the script again, we have one error saying that the name is not resolved, and we have another error saying that we failed to fetch. So that's an example of a fetch error. That's an example of a DOM error. We might have extract JSON. So sometimes we will be handling strings of JSON and we want to use JSON.parse to return that data to us in a usable format as an object that we can interact with. Yeah, we all do it, by the way. This is a good example of developers making mistakes. I'm writing code on the fly. I'm going to be making plenty myself. Luckily, this session's about errors, so you'll never know if it's intentional or not. JSON.parse, return JSON.parse. Okay, so this is all great if we give it something like this. Hello world. So if we use this function like so, it's going to be happy because we are passing in some data that is familiar to JSON.parse. But if we try to pass in, for example, HTML, that's not what this function is for. And we have an uncaught syntax error, unexpected token in JSON position 0. So what does that mean? Unexpected token less than symbol. Well, that's the less than symbol. It's the beginning of our HTML string. So often when you're fetching and you're expecting to receive JSON as a result, you may have accidentally hit a 404 page. So you might have gotten the address wrong and the server's responded with an HTML 404 page. And now you're trying to pass that into a function that's meant to deal with JSON, not HTML. So naturally this will create an error, and we need to know that that error has occurred so that we can find the place where something has gone wrong, in this case here. Okay, so we have these 3 cases and we can handle them each. So I'm going to clean this up a little bit. I'm going to say function case 1. Okay, so case 1, we're trying to find a non-existent button. And just to prove that it doesn't always show an error, I will place a button there. And we can say hello world. So case 1 should work. Hello world. And there's our button. Now, if we remove the button, we're going to break our case. We have uncaught type error, cannot read properties of null, because we're trying to access inner text, but the button doesn't exist. So it can't have any inner text. It doesn't make any sense, and there needs to be an error. So how do we handle errors? With a try catch block. This is something that takes a little bit of getting used to, because it's a little different to how a function will normally flow, i.e. a function flows from left to right, top to bottom. Whereas with a try catch block, that is not quite the case, and we'll see why. So firstly, we're going to place our code that we wrote earlier inside of the try block. And what this means is, try, attempt, give it a go. If it doesn't work, there's going to be an error. That's what it means to have not worked. So if something goes wrong, if anything goes wrong on these 2 lines of code, then that will be represented as an error in the catch block. And now we've moved execution to here. So this was attempted, it didn't work, and now we're going to do this instead. So a common thing for a developer to do is to warn another developer or themselves that the technical error has occurred. So now when we try and do this, we have an orange box instead of a red box saying something went wrong that you should probably know about as a developer, but it wasn't serious enough to completely interrupt the application. I'll come back to this. For now, that is going to be the extent of what we're doing to handle this error. We're just going to warn the developer because we don't care about our users. We don't care about their feelings. And so this is fine for now. Case 2, our async function. So async function, and we can just take this, wait. I'm also going to request a fake property. So there's going to be two errors, two different types of errors in this function. We've got fetching a website that doesn't exist, and then we've got attempting to access some data from the response that doesn't exist. So we have our warning that we created as in the catch block of the first case, and then we have our two uncaught errors. We don't even get here because the error that happens here stops this function, stops execution. So we never actually get an opportunity to make the second error, which is part of the lesson here is as soon as an error occurs, let's say an error occurs right here. That's where the application stops running that function. Nothing below is going to get considered. So that's why it is important to consider when errors might be happening. So fetch is quite error prone because there's a lot that can go wrong with a network request. So it makes sense to wrap it in a try catch block as well. So we're going to take all of this and we're going to put that in the try block so that if anything goes wrong during this fetch operation, we're going to land here with hopefully a useful error message, and we have an opportunity to do something about it. So once again, for now, I'm just going to warn the developer. And now we have two warnings, failed to fetch, and we have cannot read properties of null. Case 1, case 2. You see here, this is, if you toggle this arrow down, this is called the slack trace. And if you're using a framework, this is going to be huge. It's going to be a long list that's not very helpful. But in our case, because we have a simple application with very few files, we can see that the problem occurred in the function called case 1, and that is housed on an index file on line 6, or at least that's where we were notified. So we know that this is the source of this message just from clicking here. So case 2 is handled. Case 3 is our extract JSON. So we're just going to take all of this, put it in our try block, create the catch block. Okay, and warn developer. Unexpected string, really? Okay, yeah. So case 3, JSON, unexpected token in JSON. So now we have a grip on the errors. We've handled them in a very, very basic way. But most importantly, we have them in our hands. So the question of what to do next is part of the job of a developer. Some errors are going to be unimportant and they can be skipped or even ignored, or they don't need to be shown to the user at all because the user doesn't care at all. For example, if your Facebook tracking code fails to load on your website and the user, their behavior can't be tracked on a particular website, it's not worth telling the user that that tracking process has failed because they probably don't want to know it was there in the first place. You shouldn't make them aware of that if they don't need to be aware of it. So the decision to show the user a message and exactly what information you're going to provide in that message, that is a big part of what it means to be a front-end developer. So let's go back over those functions and be a little bit more considerate to the user. So case 1, we are going to rename that to get button. We're still going to console warn because it's still useful for the developer to see the specific error message. But we're going to show the user a different message. We could not find a button. I mean, we as in the application could not find a button, right? Now we have a message that is designed for the user. It's written in the target language of the user, and it should make sense of the error in a way that they can appreciate. Okay, the app was meant to find a button and they couldn't find it. Not particularly relevant to a user, but if you have to know about that, then that's the sort of most plain speaking way to put it. So how would we describe the other errors? This one is, we're calling get fake website. And we're going to alert the user to the fact that data stored on a remote server could not be located. So something's gone wrong with the process of getting the data from a server and placing it into the application. And finally, probably the easiest one to write, incorrect input for JSON, or we could say JSON.parse received. Okay, good thing I have a code spell checker application here, thanks to Martin. JSON.parse received the wrong type of input. There we go. So these alerts are not, we don't really use them in front-end development too much because we have nicer ways of showing these things. So we're probably going to be showing HTML instead of an alert box. The point of this particular, the use of me using alert here is to demonstrate that there is a difference between the developer's error and the user's error. They need to be told slightly different things. If we do this in every case, and then we try and imagine that we've never interacted with software before in any way, even sort of HTML, CSS type stuff. Okay, so the user is going to be seeing type error, cannot read properties of null. This is the kind of error that I was talking about in the introduction. This is annoying. This doesn't mean anything unless you are a JavaScript developer. You shouldn't really expose your users directly to technical errors unless your users are expected to be technical users. So in this case, for the purposes of a class, I might be fine showing the exact error message because everyone here is training to become a developer. And so we should be exposed to these kinds of messages. But if we are thinking about our users, they don't know what JSON is. They don't even know that lists start with 0. They probably don't know what syntax means in the context. It's just confusing and messy and not very helpful. Failed to fetch what? So that's why we have our human-friendly errors, and then I can make a little function just to show a nice error. So I'm going to create an element called div. Oops, can't use that. Div.class.add error. That's a sensible class name to give this. Error div.innerText. Actually, what we're going to do is we're going to make another element. A pre-element is pre-formatted, and what that means is that you can paste, you can show a string, and it will not interrupt the formatting that string came with. So it will be shown exactly how you got it, which can be very useful. So pre.innerText equals error. That means we're going to see the error almost exactly how JavaScript will show us, and then place the pre into the div and place the div into the body. So this is going to show us a new error. They're going to list the errors basically. So here I can say error message. And instead of alerting, we're going to show error message. Okay, so there we go. The application could not find a button. Oh, I didn't need the pre-tag after all. Tell you what, slightly ignore this 1 second. I'm going to do both. I'm going to add the technical error message, and I'm going to add no, I'm not. Sorry, I'm going down a rabbit hole here. I just didn't need to use a pre. Use too much code. Sometimes it happens. There we go. Okay, application could not find a button. If we go to the Bootstrap website, which is what I'm using to save time with CSS, I'm going to go to alerts, and they have a little danger alert. So I'm going to go and copy paste, not steal that code, and take a look at it quickly. Alert, danger. So those are the classes that it needs. Alert. Alert, danger. Why you know work? Maybe I'm not using this correctly. There we go. So I just added some Bootstrap styles to div, and now we have a better error indicator than we had before. And if I do that, the same thing for all of them, I just need to move the message. Okay. So now when we run all of our cases, we see 3 errors. They're in English, or even JSON.parse. That's not a great message. How's this? The computer didn't understand the type of data it was given. The reason this doesn't, like, the reason I'm laughing is because you wouldn't really expose like that error directly to a user. Like that error is going to represent something else going wrong. For example, if you are loading a save file and the save file is broken, then you're going to get an error saying your save file is broken. You're not going to get an error saying something went wrong with JSON.parse. It's quite hard to sort of make that abstraction without an existing application that I can look at, but I'm trying to keep this simple. So far we have handled our errors in the sense that we have just shown the error the user a message, and we've warned the developer that something went wrong. But there's more that we can do than that. So get fake website. We might expect this function to actually give us some data. So it might be that we say const data equals await get fake website. Maybe that should be called get fake website data. Okay, so this is an API call, and we're expecting to receive some sort of data back from the API when it's done. If there's an error, obviously that data is not available. So this is going to return undefined. If we take this away, it always returns undefined. If we add that return statement, it sometimes returns data and sometimes it returns undefined, because there's nothing in the catch block saying return. So why would we want to return a value from the catch block? I'm going to make a new example for this. So I'm going to say function get data from local storage. And we're going to have a key, which is going to be the name of the data set that we're trying to get. We're going to have a try catch block. And we're going to have a finally block. The finally block is going to run no matter what happens, whether it succeeds or it fails. Finally is going to run afterwards, no matter what. So in try, we're going to have local storage dot get item key. Should be pretty easy. We also want to pass that content in case it's encoded. And we probably just want to actually, yeah, we're going to want to return that data ultimately. So let data to return equals an empty array, because I'm expecting a list of items here. So if I call this here, list of products, that's the thing that I want to get from local storage. I'm expecting it to be an array. I'm expecting this data to return, I'm expecting this to give me an array. I don't know for sure it's going to give me an array because this string that's stored here could be anything. As we saw here, it could be HTML instead of JSON. So we have tried to pass it using JSON.parse. If there's an error, we're going to want to warn about that error. And finally, we're going to want to return the data to return. So what does this mean? It means that even if you try and access something that doesn't exist or is malformed, it's not in the correct encoding, there's something wrong with it, at the very least, your result is going to be an array, and the length is going to be 0 because it is because it's an array with 0 items, because nothing could be found. So this is an example of not just using the catch block to inform someone that an error happened, but actually doing something about it. So in this case, we always return an array. It's either going to be the data we want, or it's going to be an empty array. When we're using this, we can just say if result.length, and then use this data. If there's no result.length, then we might want to show a message saying there were no results. The fact that there were no results is more relevant to the user than the fact that JSON.parse failed. I don't actually know how that's going to run. Let's see how that runs. Top level await. Of course. Okay, so I have to make this its own case because I'm trying to be naughty. So this was get bad data from local storage. Okay. Okay, yeah, that makes sense. Still getting the top level. Where am I doing a top level await? Oh, here. So what do we get here? We've got an error on line 66 if result.length. So what does the error say? So this is a real error. I didn't expect this to happen. So it cannot read properties of null. So I'm trying to read the property length here, but length is 0. Why is length 0? Length should be, oh, sorry, result should be, you can see what I did wrong. This should always return null. Why does that return null? Let's see if this works without the finally block. No. Okay, so I've done something wrong here. I can't see what it is. Oh, right. This succeeds. Okay, this is actually a really good example. This is a really good example. So this is an example of something succeeding when I expected it to fail. So I wanted this to create an error, and it actually succeeded. And I don't want that behavior, because this is looked for an item. It hasn't found the item. It's returned null. This is accepted null and also returned null. So as far as the try block is concerned, everything went fine. We didn't ask it to do anything illegal. We didn't actually create an error by doing this. If I was to add, that's what I should do. I'm going to local storage dot add item set item example, and I'm going to make this example HTML. So this is not something that this function is going to be able to handle. Okay, so that's better, right? So now we see our empty array come through, because it tried to turn this into JSON data for like an array, and it couldn't do that. And so instead, it gave us the empty array. In the process of getting that right, I realized that there was a case where there should be an error, in my opinion, where there's not an error. So I actually want to create my own error here, which is something that might seem a little strange. Why would you create extra errors instead of reducing the number of errors? Well, sometimes it makes life easier. So in this case, we're going to see what was stored here, or I'll just call it item. So we'll see what the item is here. And if the item is null, i.e., if there's no item, then we need to do something about it here. So do something. If there is an item, that's fine, because we can pass it in, and now we can change this to item because we've already stored that data. So now we have, if there's no item, do something, otherwise continue what you were doing before and return the passed result. And I will explain in a second what JSON.parse does. So what do we want to do here? Well, we could show an error and say nothing was found in storage. But we shouldn't, because that's not what the try block is for. That's what the catch block is for. Here we have a situation which is an error in the context of our function, but it's not an error in the context of JavaScript. We don't want this function to continue if there's no item found. So what do? Like a child, we throw a fit or a tantrum, except that's called an error in JavaScript land. So we need to throw a new error because we have decided something has gone wrong and we know better than JavaScript. So we're going to say no items found with the key. And then it might be helpful to include what the key actually was. So now we have a function that accepts a string key. It tries to access that in local storage. If it doesn't find anything, it will throw a new error. Otherwise, it will return the data for that item. actually, we can just pass that error indirectly. Actually, yeah, let's pass the error indirectly because there will be two possible errors here. There's either going to be nothing found error, or there's going to be a pass error. And that depends on what we're trying to access. So now, actually, I'm just going to get rid of these other calls to make it less confusing. Okay, so we should just be running the one there. Okay, so we have our warning in the console. We have our kind of unhelpful warning for the user here. And we have our result, which is the empty array. So we still get our result. And we can still interact with that to a degree. But this means that if nothing was found, or if there was an error, you'll get an empty array. So let's fix the local storage thing, set item, and we're going to give it a nice item. And the nice item is going to be an array. And now the key is going to change to nice item. And there's no error because everything went fine. It did exactly what it meant to, and it gave us an array with two items in it. If we do this as well, hello world. So that's our result. It's working exactly as we intended it to. There's nothing wrong. If I try and say nice item 2, that item doesn't exist. So it's going to trigger this error. Error, no items found with the key nice item 2. In our result, we have an empty array with a length of 0. So that's quite a good position to be in as a developer because your users had some sort of information about what went wrong. The developers can see exactly what the error is, and you still have something in JavaScript that you can interact with and say, if result.length is less than 3, then show message, show error, well, error, I guess. Results should be more than 3. So in this case, we've handled an error in multiple different ways. We've handled it with the developer, with the user, and with the runtime. Not all functions need to be handled so intensely, but it is a good idea to have some sort of strategy in place, even if you're just console warning errors for yourself to help your own development. One of the best cases or best examples of when to use throw is if you're dealing with a fetch request. So I'm going to create another async function, and we're going to do another. We need to perform get wrong endpoint from right API. Okay, so what's an easy to use API? Let me think. Fake JSON placeholder. JSON placeholder, there we go. Okay, so this is a very nice, easy to use one. I'm going to go with posts. So take this link and say my posts. We're going to try await fetch. we're going to get the data from the request, and we want to return the data ultimately. And we're going to leave that blank for now. The reason we want to return the data is so that we can actually use this. Well, I can't use it at the top level, but just to give you an idea, the data equals await. So if we want the data to be populated with the result here, we have to return it from this function. But there's something that happens here that not many people know about. So most people will quite happily go through this process and return whatever this is based on whatever this is, assuming that if something goes wrong with the request, they're going to land in their catch block. Something went wrong. The request. So unfortunately, that's not true. There are lots of things that can go wrong here that won't take you to the catch block. If this API URL exists and there is a server on the other end to respond to your question, then you're probably not ever going to land in the catch block, even if you mess up the URL like that. So let's test this out and see what happens if we hit a real API and we hit it in the wrong way. I've got my same message about not using top level await. Okay. So when I run this, I see a message saying that the request didn't go correctly, but I don't see my warning. And just to make it extra obvious, let's put request error. Okay, there's an error, but none of our error handling stuff is actually kicking. Why is that? The reason is that it's an error for us. It's not an error for the server. We've asked the server a question. We've said, what do you have at the address? And then a load of gibberish. And the server has accepted our question and said, thanks for the question. The answer is nothing. I don't have anything at that address. So here's a nothing response saying I have nothing, which is called a 404. A 404 is a real response. So as far as we're concerned in here, this response is a 404. And now we're expecting to get the data and return the data as if it's going to be the data we want, but it's not. So that's going to create a lot of issues. So what do we do about it? We can check the response dot status. So if I console log this, if I console log the request status, we're going to see it's 404. We can also ask for response.status text. 404, nothing to say really. Sometimes error messages will have a, for example, if you're submitting a form and there's a required field and you don't include that required field, it will often say 400 error, which is bad user input. And the message will say the field email is required and it wasn't included. So in our case, there's nothing really to say about it, but we don't want to return a 404 because that's not useful to us. That's not what this function is for. So we've got to step in and do something about it before then. Luckily, we have something called response.ok. So if the response was okay, it means it's either a 200 success or it's a 300, which means that the file's been moved, but it's still a success. So if response.ok, then we can return our data because everything went fine. We asked for the data, we got the data, the response is okay, there's nothing to worry about. So all's good. But if the response isn't okay, then we need to do something about it. And the thing we need to do about it is tell the user. So this is a great place to throw a new error. And we can pass in our own error here. Response was not okay. And we might want to add the error code. So now if we receive a 404, instead of returning the data, we're going to throw a new error to the catch block. And there we go, request error. That's, oh, okay. I'm gonna put this in here. Okay, error response was not okay, code 404. If we fix this, then we don't get the error. We break it, we do get the error. This little bit of code is a bit of a lifesaver, and it's something that I don't see very often. In fact, I don't think I've ever seen it when marking students' work. And this is missing a huge amount of the transaction that happens when you fetch from an API. So you don't have to throw an error as long as you do something about it here. But you shouldn't be going through a fetch cycle expecting absolutely everything to be okay. And if it's not okay, that will always show up in the catch block. There are times when an error is an error to me, but not to you, and vice versa. And that's why we have throw new error, is when we need to inform the application that something that's happening should be an error when it's not. So we're producing more guards for ourselves. I've got one more example. I know we're a little bit over an hour, but the last example I'm going to do is a function that creates some HTML. So we're going to create a product. So the things we might want for the product are going to be a name, a price, a category, and that's probably fine. And I actually know, yeah, that's fine. A name, price, and a category. So we could just do this. Name, price, category. That's the lazy way of doing it. Laptop, price, 200, 2000, category, tech. Okay. Okay, so we've created a product called laptop, and if we console log that, we have name, tech, category, name, price. Great, exactly as we want it to be. Very little code, very simple. But there's stuff that can go wrong. So we expect this to be a string. We expect this to be a number. And maybe we expect this to be an array. I haven't actually said. Maybe we can call it categories and expect it to be an array. So it should be like this. Tech, and we'll say Apple. And category is not defined. Here we go. Okay, so now we have our array, we have our name, and we have our price. So what happens if I create a bad product? And the name of the bad product is going to be an object called the name. The price is going to be a string, 20 quid, and the categories are going to be they'll just be one. Okay, clearly this is not how we want our function to be used, and it produces something that works, as in doesn't throw an error. JavaScript's quite happy with what we've asked it to do here, but the format of this is completely different to the format of this. And if we try and work on these two objects in the same way, we're going to have issues. We need to know that they're all going to be the same. They're all going to be formatted the same. So what can we do about that? Well, in this case, we don't necessarily need a try-catch block, but we do need to check our inputs. So if no name, so if the user didn't supply a name, we're going to tell them that that's an error. Name is required. If the type of name is not a string, we're going to throw a new error saying name should be a string. And then we're going to do the same thing for price. And we're going to do the same thing. Price, it should be a number. Now I know this is like a little bit aggressive, as in this is a lot of code to be adding to a very small function. And my argument for this is that this particular function is critical to the business of a bank. So they need this function to be extremely rigorous and never ever go wrong. That's why I'm going to such lengths to make sure that this is tightly handled. Okay, so categories and categories should be an array. Okay, so before we do anything, we've got 6 chances for something to go wrong and for an error to be created. Now, if we run the same script again, we can see a real error. It's uncaught, as in it's just the same as when you make a syntax error or there's a fetch error and doesn't get handled. This hasn't been handled. That's what uncaught means. Categories should be an array. That's the mistake we made. If we change our bad example, give it a name, but nothing else, category should be an array. Why is it always going through? Oh, it's okay. There we go. I made a mistake. See, mistakes happen all the time. So I was saying if the array is an array, it should throw an error, and I meant the opposite of that. I meant if it's not an array, it should throw an error. Okay, so now price is required because I didn't include a price here. If I include a price but don't include an array, categories is required. If I include the wrong thing for an array, categories should be an array. If I include the wrong thing for name, name should be a string. So you can see how by using throw error and a few very simple conditions, I've made this function harder to use. I've made it harder to use, but I've made its output much more reliable, we can be sure that when this thing actually gets round to here, creating an array, that, sorry, an object, that everything is exactly how it should be. Because if anything was wrong, it will have been interrupted by one of these errors. So these are like safety nets that you're throwing down before you start working on your function. You don't necessarily need 8 of them. If you are clever, you can actually write a sort of generic error case. You know, I could just group all of these conditions together and say, if any of these fail, there's going to be an error. The problem with that is that you just have to be less and less specific about exactly what the error was. So bad input. I'm not going to do all of them, but just for the sake of argument. So now, what do I do? I should be using or. Okay, there we go. So now if any of these conditions fail, it's going to throw one error and the error says bad input. That's another way to skin the cat, but I don't mind this sort of thing because at least it's very clear. You know, if you're reading this code, you're not going to be in any confusion about what this function is meant to be doing. As it happens in TypeScript, this can be done much more nicely. We don't have to do all of this. We can just specify which type each of these arguments should be, but that's for another day. Right, so that is about as much as I'm going to be able to cover in the time. I know we had a bit of chat. Some of it was about my haircut, some of it was about JSON parse, some of it was about inner HTML. So I will do some Q&A now. If anyone has any questions about what I've just been speaking about, then put those in the chat. Otherwise, I'm going to start my way from the top. Okay, so first one is, what does JSON.parse do? When we have a JavaScript file, example.js. So when we have a JavaScript file and we have an object, this is this can be written like this, something, or it can be written without the quotes. There's no, you know, as long as this is valid, it's valid. Like it doesn't have to be one way or the other. In JSON, every property must be surrounded by quotes. Only certain values are allowed. So there's a slight difference between data in JavaScript and JSON. And we can actually stick in the original file and just make sure that we're not calling anything. Okay, so we can show this quite easily. Okay, so JSON example input. So in this example, I'm going to take whatever is passed into the function, and I'm going to turn that into a string. Then I'm going to make a pre to show that string. Should I get that just now? So inner text to answer another question that was in the chat. So inner text and inner HTML are cousins or siblings. When you're inserting inner text, you are not inserting any HTML. You're literally like h1.innerText equals hello. You're saying that the text that you want to place inside the h1 is hello. Whereas in a HTML, you could do the same thing and it would work. Or you could have an image tag in here as well. But if you do inner text and you try and put an image tag, it's going to literally put the image tag. Like it won't render that as HTML. It will render it as exactly what we're seeing right now. So there are subtle differences. Inner text is much safer to use. Okay, so we have a little example bot, and we're going to say JSON example. Oh, okay, one more thing. Document body, append pre, so we can actually see it. And then we're going to start with some primitive types. 1, 2, 3. And then we can have 1, 2, 3, 1, 2, 3, an array, example, and then an object. Okay, so these are calling the same function with a few different types of input values. All of those input values are going to go to json.stringify, and then we're going to see them. So this is how each of those values look once they've been converted to JSON. This you can store in a JSON file. So I can do this, copy that, make a new file, save it as data.json, paste that, save it, and it's 100% ready to go. In fact, I could even fetch it if I wanted to. I could fetch this file and get the contents and read example hello. If I make one subtle tweak to this and I put null and 2 here, then we're going to get slightly better formatting. Instead of just grouping everything as a block, it will just make everything look a little nicer. So this is an example of taking JavaScript data and turning it into JSON. Then we can do the opposite with a function decode JSON input. So the input should be a string, and we're going to return JSON.parse input. So if we store these as variables, const A, B, C, and so on. Now we can decode them again. So let's look at A, and then actually, no, that's a bad example. Let's make this more complicated. Okay, let's use example D, because that's the most complicated one. So we're going to console log the value of D, and we're going to console log the value after it's been decoded. And I've got an error. Why do I have an error? Decode input. Undefined, U for undefined. So this error told me unexpected token U, and that was the first U of the word undefined, which this isn't undefined. D is not undefined. 1 second. Undefined. It is undefined. Right. Okay. I forgot a return statement. So nothing was actually getting, JSON example wasn't passing any data. So now that's better. We can see that we've got our string of JSON that we can copy into our JSON file, and there's no errors. There's no warning that something's wrong. It's pure JSON. It's 100% ready to go. And now if we log the string and we also log the result of the decoded string, decode JSONs, oh, right. Okay. So now we have our string of data and we have our actual JavaScript representation of the same data that we can have a look through and we can interact with, and we can even store as a variable, and then we can say temp1.example equals goodbye, temp1, and then we can see that change reflected. So JSON is all about the difference between text representing data and data in memory that you can actually handle. You can't handle this in JavaScript. You can handle this in JavaScript. So that is a bit of an explainer on JSON.parse. And yeah, renaming things in VS Code, you can use F2. That's what I do. So if I want to change the name of this one, for example, I'm going to press F2 and call it encode JSON, because that's actually a better name for it. And that changes all of the references at once, which is very handy. But yeah, that's all I've got on error handling. I'm sure there was a bit too much information for some people, but hopefully I've demystified things a little bit, and especially introduced the idea that an error is something that you control and you have power over. You can create your own errors, you can suppress errors, you can handle them in lots of different ways. The only thing you shouldn't do is not handle them ever at all. That's bad. So yeah, if there's no more questions, then we will finish up for today. Cool. Cheers all.